we will continue our discussion of hybridization leading to Lewis structures and geometry and bonding and polarity. And this time we're going to do this one right here. F3CCN. I know it's organic enough. There's no charge. We know don't we know the nature of each of those atoms? I'm going to call it organic because we know the nature of all those atoms. I got 3 F's attached to a C. I'm going to go straight to the Lewis structure. F, C, F, F. Bonded to a C. Bonded to an N. All right. Lewis, this is part A. I need lone pairs. And pi bond. I don't have anything. F, what's its nature? What's missing on each F? 3 lone pairs. Don't put lone pairs on carbon, please. Don't do it. It doesn't do that. How do you fill the octets for the carbon? Pi bonds. Don't go to the left because the carbon to the left has an octet. You got to go to the right, and you need 2 pi bonds, don't you? What's nitrogen's nature? We're almost finished with it. How many bonds? 3, and how many lone pairs? 1. We need the lone pairs. Done. That's part A. It's drawn pretty well, except for there's a tetrahedral carbon there with the F's on it. We got to draw that properly for geometry. So part B, we came pretty close. Often you either come up with a perfect geometry right away, or just do a slight addition, modification. Don't need the lone pair anymore. There's 90, there's 109.5. And remember, when you're drawing a tetrahedron, where to put the wedge and the dash? They're always away from the bonds that aren't wedges or dashes. See the 2 going here? They're up here. So I want them away from those 2 bonds. That's a proper tetrahedron. You keep watching lecture videos. There's ways to draw a proper tetrahedron, and there's illegal tetrahedron. Read the book, it's also in there. Don't draw illegal tetrahedron when you're supposed to draw the right geometry. Don't need lone pairs. There's B. Let's do more systematic here so you know where B stopped and where C started. We're doing B. B's done in green, and C will be in red and black. No, what did we do last time? Blue and black. C. All right. Dipole vectors. Oh, delta En for F and C. 4 minus 2.5. 1.5, right? I'm going to go back. I'm going to grab my dipole that was exactly 1.0. This one right here. I'm going to go over and grab that. Then I'm going to realize that this needed highlighting because it was overlapping existing notes. I just want you to know that that was all one little story. It overlapped what was already on the page, just for clarity. I'm going to paste my dipole that represents exactly 1.0 and realize that thing needs to be 50% longer, correct? Is that about 50% longer? It is. I want everything to scale for the 2 pages. And then, you know, you have the optical illusion that a wedge is, it's going to look a little shorter than it really is. Once again, we got to way past this. The wedge dash phenomenon. I put them in red. Said I was going to do them blue and black. Hey, what can we do? CC. What's hey? Is there a dipole vector between a carbon and a carbon? No. They have the same electronegativity. C and N is 0.5. N, C, 3.0, 2.5. Okay, 0.5. 1/3 the length of that, pointing towards the N. Is that about right? Is that about 1/3 of that? I think so. I got my fingers going in. 1, 2, 3, maybe a little longish, but not terrible. A and B. We're going to do that down here. Oh, man. It thinks they were all done at the same time. A plus B is going to, let's see if I lose anybody. Right in between those two. And pretty long. Right? Right in between those two. Now, if you add A plus B plus C, isn't that going to be straight to the left? This is C. A plus B plus C. Okay. And then D. A plus B plus C plus D. Well, I'm just going to put the D on top of what I did here, and it comes back there, and I'm just, you know, whatever. A plus B plus C. Why so mean to me? It's just mean to me. And then the D is where that ended, A plus B plus C. Comes back that far. The net, very start, is in purple. Start, end, net, in green, start to end. So a slightly polar molecule. Okay, but not very much. Compared to our other molecules, it's less polar. They have bigger dipole. Yeah. Well, remember when I added A plus B, you were cool with that, right? Now the thing is, what do I get when I add something that these two things? One's pointing that way as much as this pointing out that way. Straight through the middle, right? Straight through the middle. Yeah, and everything's to the left. Every one of those arrows points to the left. So when you're adding them all up together, they better have to go to the left. And there it was on the left. Yeah. Once again, the wedges and dashes, I agree, they make it a little tricky. And is that the whole deal? Net. That's part D. And part C was doing all this stuff, or I guess this is all C with the vectors and stuff. B we did over again, because that was our skeleton. And now I got labels that are matching the question numbers with, that was a poor choice. I shouldn't have called this A, because there was a question A. Now you think they might be related, and they're not, right? But I think you're past that. Okay? Yeah, we had 4 vectors to add, A plus B plus C plus D. And my D looks like an A. And I labeled it twice. I don't know where I just, you know. Make it clear. Okay, that's that. That's a double activity. Yeah.